In this video, we're going to introduce 4 more functions which I would consider to be the children of sine and cosine. Sine and cosine are the 2 most important functions for this class, but their 4 children can also be convenient to use in certain situations. We're going to state the definition / the formula for the functions called tangent, cotangent, secant, and cosecant. We are going to practice evaluating those functions at certain angles. So in addition to sine and cosine, there are 4 other functions that are related to the unit circle that are occasionally used when it is convenient. The first of these functions is called tangent, and it is denoted by TAN for short. If you want to plug an angle, for example angle theta, into tangent, how would you do that? You would do that by taking that angle theta, plugging into sine, plugging it into cosine, and then dividing the 2 results. Tangent is equal to sine divided by cosine. The second child of sine and cosine is called cotangent. Cotangent, COT for short. How do you find cotangent? Much the same way as tangent, except cosine is on the top and sine is on the bottom. Secant. What is the secant function? SEC for short. That is defined by simply putting 1 in the numerator and cosine in the denominator. So it's a bit like tangent, except instead of having a sine in top and a cosine at the bottom, we have a 1 at the top instead of a sine. Cosecant. Now it may seem like we are going to once again take the first 3 letters, but if I do COS, that's the same abbreviation that we have for cosine, so that's not going to work. Instead, the cosecant function is represented by CSC for short. C for co, S for the S in secant, and here's the C in the back, that's the second C. And you might be able to guess what cosecant's formula is going to be. Secant was 1 over cosine, cosecant is 1 over sine. So these 4 formulas become quite convenient when we're working with triangles, with problems that involve triangles, and that's something that we're going to study in a bit more detail later on in the course. Videos number 17, 18, and 19 is when we'll start to see these used quite often, but this is a convenient place to introduce them. Now that we have defined the formulas for these 4 functions, we have the complete set of all 6 what are called trigonometric functions. Now the word trigonometric is just Greek for the measurement of triangles. These 6 functions are used in triangle problems, as I said just a little while ago. Now the most important of these functions are certainly sine and cosine, which are the parents of the other ones. The next most important is tangent, that comes up more frequently than the remaining 3 functions, which I would say cotangent, secant, and cosecant are not really used that often at all. So as you're working with these formulas, bear in mind that generally speaking, sine and cosine are the most important of all, with tangent following slightly behind in importance, and the rest of these are used much less frequently. I would recommend to memorize the definitions of these 4 functions here, because you do end up using them pretty often in this class and fairly often in calculus as well. So let's get some practice plugging angles into these functions. For example, how would I evaluate tangent with the angle pi over 4 plugged in? If I want to evaluate tangent of pi over 4, then according to the formula, all I need to do is take sine of that angle and divide it by cosine of that angle. So pause the video for a minute, go back to that reference circle, and figure out the values of sine and cosine with pi over 4 plugged in. So looking at that circle, you should have the value of square root 2 over 2 for sine, and the same value, square root 2 over 2 for cosine. But because I'm dividing a quantity by its own self, whenever you divide a number by itself, the answer is 1. So the value of tangent of pi over 4 is equal to 1. We really didn't have to do anything that was that different from what we've done before. We just had to go to the unit circle, pull the values of sine and cosine at pi half, and then put them into this fraction and calculate the value of the fraction. That's how we can figure out tangent. What about secant? Someone says evaluate secant of pi over 3. So I'm going to use the fact that secant of pi over 3 is equivalent to 1 divided by cosine of pi over 3. So go back to that circle for just a second, go back to the circle and figure out what's the value of cosine of pi over 3. So cosine of pi over 3, or cosine of 60 degrees, is equivalent to 1/2. So secant would be equal to the reciprocal, 1 divided by 1/2. So if I flip 1/2 upside down, I just get the number 2. Secant is equal to 2. Let's get some more practice with these formulas. At what values of theta are tangent and secant undefined? So let's examine this formula for tangent, sine theta divided by cos theta, and this formula for secant. Secant theta equals 1 divided by cos theta. Now, just as an aside, notice I'm using that alternative function notation for trig functions where you don't necessarily have to put parentheses around the input. Now, one of the ways to make something undefined is to divide by 0. Division by 0 makes something undefined. And what I'm noticing is that both tangent and secant have this property that cosine is in the denominator. So if that cosine ever ends up being equal to 0, then the quantities tangent and secant will end up being undefined, because if we divide by 0, you get an undefined quantity. So in answer to this question, let's try and figure out the angles that would cause this cosine in the denominator to be 0. Now, once again, if you're faced with a problem containing sine and or cosine, and you're having a little bit of trouble getting started on the problem, a good reflex is to try right away to draw a unit circle to see if the unit circle will help you to answer the question. If we want cosine to equal 0, that means that we want the x-coordinate on the unit circle to equal 0. And there are 2 locations on the unit circle where you have not moved any to the left or to the right, where you're right in the center, and that's this location and this location. So let's try and figure out which angles might point to these 2 locations. If the angle points to one of these 2 locations, then cosine will be 0 at such a location, and that will cause us to divide by 0 in the formulas for tan and secant, which will cause those 2 functions to be undefined. So just having a look at the picture, I can identify 2 angles that will lead to these 2 locations, and one is a counterclockwise rotation of 1/4 of a full spin, or in other words, 90 degrees. That will bring us to the location at the top of the circle where x is 0. And likewise, if we wanted to go to the bottom where x is 0, then we would end up with theta equals negative 90 degrees. Of course, each of these angles is just describing one possible way to reach these two directions. There are a bunch of other angles which are coterminal to 90 and negative 90, which will also point to the same direction and will give us the same cosine value. So I'll add or any angle coterminal to these. For example, theta equals 270 would also point straight down, would also point to a location where cosine is 0, and therefore would also point to a location where tan and secant are undefined. What about cotangent and cosecant? What values of theta are not allowed to be plugged into these functions? What values of theta would cause these functions to become undefined? So let's have a close look at their formulas. Cotangent had a cosine in the numerator and a sine in the denominator. Cosecant had a 1 in the numerator and a sine in the denominator. Once again, we know we can't divide by 0. But this time, sine of theta is the thing that's being divided. So this time, we're interested in what values of theta will cause that sine in the denominator to become 0. So let's try and figure out the angles that will cause sine to produce a value of 0. Once again, if you're ever in doubt, bust out a drawing of the unit circle and see what it might tell you. In this case, because we're dealing with sine, we're looking for places where the y on the unit circle is equal to 0, which will be places where you haven't gone up or down at all, places which are right in the middle in terms of heights. So that'll be this location on the far right and this location on the far left. So let's figure out what angles correspond to these two locations. The first angle that occurs to me, an angle that points to this location on the far right, is the angle theta equals 0 degrees. If you just start facing the starting direction and don't turn to the left or right at all, then you will be pointed to the location 1, 0, where the y value, the sine, is equal to 0. How would I reach the other point? What angle is going to get me to this gold point on the left, where the y is equal to 0 over there as well? That's an angle of pi radians, aka 180 degrees. At these two angles, the y-coordinate on the unit circle is 0, and therefore sine of theta is 0, and therefore cotangent and cosecant are undefined. And just like in the previous exercise, any angle which is coterminal to these two will also cause the same problem of division by 0. So if someone asks you to evaluate tangent of 90 degrees, which would be equal to sine of 90 degrees over cosine of 90 degrees, something like this, 1 over 0, is not possible. 90 degrees is a number that cannot actually be plugged in to tangent, not if you hope to get an actual number out. So this is going to be a lot like, for example, something like 1 over x. If you have this function, you can't plug in 0, or something like the square root of x. Unless you're dealing with imaginary numbers, which we're usually not, you would not be able to plug in -1. You can't take the square root of a negative number unless you're involving imaginary numbers. And like the natural log. Natural log and any other log of any other base, we can't plug in something like x equals 0 or x equals -1. The natural log, you can only ever plug strictly positive values into that function. So for some of these other 4 trig functions, there are certain values that cannot go in, because in the formula you end up dividing by 0, which isn't possible. That concludes today's material. When we return tomorrow, we're going to use the unit circle and the formulas for these functions to figure out some properties that these functions must satisfy.